Alright, 7.1, an entire lesson on modeling linear relationships in slope-intercept form. So we're going to be using slope-intercept form for all of this. Alright. Let's get started. It says a department store offers frequent buyer cards to earn rewards for purchasing customers for purchases customers make at the store. Each transaction is worth 12 points. The customer automatically earns 25 points when they sign up. So we're going to write an equation for the function that gives the card value based on the number of transactions. So I'm going to say card value based on the number of transactions that have occurred. All right. What units could be associated with the variables of this function? We're going to say variables are card values and transactions, and our units are going to be points. Right. Complete the verbal model for the frequent buyer card, including units. Alright, so we've got card value points equals initial value points, and then what we're going to add, we're going to say purchase value. Purchase value. Alright, there should be a U in there, it's hard to see. And that is times, well, this is points per transaction, and this is over here, right, your number of transactions. So transactions, that's how we get points. So what if we go ahead and write a regular one? So our purchase value, we start off with 25, right, and then we get 12, right, points per transaction. Not too bad, right? There was our start, the 25, and there's our rule, 12 per transaction. For each 100 points, the customer receives a gift card. How many transactions will it take? Well, we want 100 to be our output, so we're going to say C sub t equals 100. Let's do it. How long will it take me to get 100 if I start with 25 and I earn 12 every time? Subtract 25, 75 equals 12t, divide by 12, and we get 6.25 equals the number of transactions. Now it can't be 6.25, right? Because you can't have a quarter of a transaction. So we're going to say it will take 7 transactions to earn first gift. What is the y-intercept? Well, the y-intercept is going to be our start value always. Alright, so that's 25. I'm going to say beginning points. Alright. What is the slope? And what does it enter? Well, the slope is 12. And that's points per transaction. Let's keep going. Let's see what's on the other side here. Alright. Well, use the function rule to show that the units for C sub t are points. Well, we start with points, and then we add points per transaction, and then we multiply by transactions. Alright, look what happens. These guys cancel off, and that would give us just points. Alright. What type of numbers are appropriate for the domain? Well, probably whole numbers, right? Because we can't really go negative. So we'll say whole numbers. No negative. Ooh, I should negative. We can't really have a fraction, so we'll say or fractions, right? Can't have a half of a transaction. Restrictions on the range. Well, we start at 25 and go up, right? So I'd say my range, the output, is greater than or equal to 25. Can't go 24 because we started 25. Let's do one more. Let's keep going. Let's work. Alright. This says, given the real world situation, solve the problem. Fundraising. Alright. Band Booster Club is selling t-shirts and blanket wraps to raise money. Band director asks the club to raise at least 1,000. Alright, here we go. Booster president wants to know how many t-shirts and how many blanket wraps the club needs to sell to meet their goal of 1,000. Okay. T-shirts cost 10 each. Blanket wraps cost 25 each. Write a linear to describe the problem, then describe the linear equation. How can the Booster Club president use the sale price of each item to meet the goal? Well, you know what? Probably be easier to start this in a different format, but here we go. The teacher cost is going to be, t-shirt is $10 each. We got that from above. The blanket wrap cost is $25. We can see that up there too. We underlined it. Alright. The Booster Club needs to raise 1,000. Well, there's our basics. Total around revenues earning t-shirts is 10 per t-shirt, right? $10 per tee. The amount of revenue earned from selling blankets is 25 per blanket. These results can be added and set equal to the sale goal. That's a good point. To find the number of t-shirts and blankets needed to be sold to reach 1,000. Graph this function to find all the possible combinations of t-shirts and blankets sold to reach 1,000. So to write this is kind of easy. It's better to start a problem like this in standard form, right? We would say 10b plus 25t is 1,000, which makes sense. You don't have to worry about slope or anything yet. Alright, let's keep going. 303 is right here. Alright, let's rewrite it. We had 10t plus 25. What was it? I forgot. I'm sorry, let me rewrite that. 10b plus 25t equals 1,000, like that. And then, since we started in standard form, what we're going to do is we're just going to find the y-intercept and the x-intercept. Alright, so I want to find how many b's. I just cover my t's. That's my, well, in this case, we'll say y-intercept, right? And that goes into that 100 times. Or we can make this x-intercept. It doesn't really matter, right? Alright. And if I cover 25 like this, I get, what do I get? 40. Ooh, I did that wrong. Let's put the 40 here. We'll put the 100 here for my other intercept. Alright. My y-intercept, if b was 0, it would be 40, right? If b was, or t was 0 actually, it would take 100 blankets. So let's do our values over here. Number of blankets sold. This is going to be blankets over here. And this is going to be t-shirts. Let's make sure we got this right. So if t-shirts were 0, blankets, oh, I did that wrong. Let's switch this. Let's do t-shirts here. And over here we'll say blankets because we have to have enough. And I'm going to have to fill this in again. Let's think about it. So if t-shirts here is 0, blankets would be 100. It's going to be 0, 100. I'm going to put it right here. Right? If blankets was 0, t-shirts, this guy over here is going to be 40. So I'm going to go up to 40 right here. And then if we connect it, we're going to be from there to there. That's the combinations. Sorry, that was a little rough. And if t-shirts were 50, you know, there was my problem. This 50 is probably throwing me off. There would be no blankets. That's t-shirts of 50. I think this worksheet is a little faulty here. But we can graph it with just those two, and it's not too bad. Alright. So our y-intercepts right here is going to be the number of t-shirts, right? This is t-shirts. We'll say t-shirts. This is better. That need to be sold if no blankets are sold. That's going to be our y-intercept. Let's change this to y, and we'll change this to x. The x-intercept right here is the number of blankets to be sold if no t-shirts. They switched these up. The book made a little mistake on this for this to work out. The Booster Club president can use the line, this line here, to find the possible combination of t-shirts and blankets to reach 1,000. Alright, there's just a little bit more. In fact, there's really only one problem more. I'm going to put it on the next page just in case this has a hard time saving. We're going to do one more with this problem right here, and we'll be right back.